In today's lecture, we will read linear regression, and this lecture is especially meant for ISC students, and this is the syllabus for linear regression. In this lecture, our emphasis will be first on concept, and then we will illustrate some examples so that these concepts can be appreciated. You all are aware of a straight line equation y is equal to mx plus c. When we have data in such a way that all observations are lying on a straight line, the thing is very simple. Here c is intercept, m is slope, x is known as independent variable, and y is dependent variable. But the situation will change when these data we have found after observation are not lying on a single straight line. We will have to fit a straight line to estimate the value of y. That is why there is the need of regression. Through regression, we are estimating dependent variable y in this equation. We are estimating dependent variable y. For the sake of completeness and taking care of your syllabus, we will use y is equal to a plus bx as an equation for a straight line, where a is intercept and b will be slope. Y here in this equation will be dependent variable and x will be an independent variable. Now, natural question is, what is the use of regression? Why we do regression? Regression is used for estimation or prediction or forecasting, and the curve we are fitting in this observation is a straight line, so we call it a linear regression. I think till now you have some feeling of the subject. Now let us know what is a scatter diagram. What is a scatter diagram? A scatter diagram is a mathematical diagram. A scatter diagram is a mathematical diagram to display values of two variables for a set of data. And what is its use? A scatter diagram is used to investigate the possible relationship between the variables. Suppose after an observation or an experiment, we got the following set of data: 1 1, 2 1, 3 2, 4 2, and 5 4. After experiment, we have found the following data. Now we have to plot it. Okay, it can be plotted. This is x-axis and this is y-axis. X-axis we have values from 1 to 5, 1, 2, 3, 4, and 5. And in y-axis we have values from 1 to 4, 1, 2, 3, 4. First point 1 1, then 2 1, then 3 2, then 4 2, and finally 5 4. We have 5 data points, and as you see, these observations or data points are not lying on a single straight line. Then in such type of situation, we will have to find best fit of the line. But best fit of line, suppose somebody is using one's judgment and says that this is the best fit line, then some person will say, no, no, this is going to be the best fit line. So it is important to define what will be the best fit line. It is important to define best fitting line so that the difficulty that is arriving due to individual judgment, that can be done away with. Now our task is to define best fitting line. And for defining best fitting line, we have a concept that is known as methods of least square. Methods of least squares. Now we will study methods of least square. In this, suppose we have We have XY axis. This is our X axis and this is our Y axis. And we have various observations. Something like this. And what will be the best fit line? How we will decide? Suppose we have drawn this line, and this line to be a best fit line, there is certain requirement. And suppose we have x1 here and the whole distance this distance is y1, and this is the point of best fit line. So for sake of clarity, I am drawing the point just it will overlap here, but and this line represents the value of y on this best fitting line. So the difference of this, call it, means this portion, this vertical distance d1, this is known as d1 is known as deviation or error or residual. Vertical distance from the point of observation to the point of best fit line is known as deviation or error or residual. Likewise, we have B2 here. This is almost there. This distance, vertical distance is D4 here. This vertical distance is D5. Then we can define best fitting line when the square of each vertical lines, suppose we have n such observations and we will have this vertical distances as squares, this should be minimum. The sum of square of all the vertical distances should be minimum, then we can say that this is the best fitting line. So let me write formally the definition of best fitting line. Of all lines approximating a given set of data points, the line having the property that b1 square plus d2 square plus b3 square plus dn square is a minimum, is called a best fitting line. Now we can say that what will be the best fitting line? This line will be a best fitting line if d1 square plus d2 square plus d3 square plus d4 square plus dn square, the sum of all these vertical distances is the sum of the square of all vertical distances is minimum. Then this line will be a best fitting line. And just let me write d1. What is d1? It is, as we have seen, difference between the value y1, that is from observation, and the corresponding value as determined from the line. We have seen here, this is the vertical distance of observation first, x1, y1, and this is the vertical distance from this line, and the difference of the two, this part is d1. Just we have defined best fitting line, a line having this property, that is the sum of d1 square plus d2 square plus d3 square plus dn square is minimum, is said to fit the data in the least squares line. Now we have understood what is best fitting line through this methods of least square. Minimization of summation of d1 square plus d2 square plus dn square is known as method of least squares. Okay. Now the next topic, the least square lines. It is very important concept and just try to understand it. It is very easy. The least squares line approximate the set of points as we have seen x1 y1, these are set of the points x2 y2 x3 y3 xn yn has the equation y is equal to a plus bx. This line we have just mentioned here. This has the equation of y is equal to a plus bx as this fitting lines equation. List this is y is equal to a plus bx. Let us call it 1. Here a is intercept, b is slope, x is independent variable, and y is dependent variable. Where the constants a and b are determined by solving simultaneously the equations sigma y is equal to an plus b sigma x and sigma xy is equal to a sigma x plus b sigma x square. Let us call it equation 2, and these two equations are known as normal equations. These two equations can be derived by minimizing d1 square plus d2 square plus dn square. We have to minimize it. One approach is for finding this normal equation, we have to minimize this equation, minimize sum of squares of these vertical distances. We will discuss this method in some other lecture, but for now, for remembering, mind it, what we have written here is for the sake of remembering. How these equations we can use for remembering? We have equation y is equal to a plus bx. For writing equation 2, we will apply summation on both sides of equation 1. This is equation 1. Thus, it will be sigma y, and apply this sigma a here and apply this sigma on here. And for your knowledge, let me confirm it that this summation of sigma is from 1 to n. For sake of simplicity, we are writing sigma here, but this sigma has been applied from I barabar 1 to n terms. Okay, sigma y is equal to, and when you are writing a is a constant, and if you write a n times, then you will get na. B is a constant, so it will be out of sigma. Thus, we can see that we have arrived on first normal equation. Just we have written here how this has been got. It is very simple, but it is not the derivation. It is just for remembering. And now for writing equation 3, what we will have to do? First, we will multiply equation 1 by x on both sides. What will it become? xy is equal to ax plus bx square. Okay, on y is equal to a plus bx, we have multiplied by x on both sides. So now this equation is in this form, and now we are applying sigma on both sides. Or sigma xy is equal to sigma ax plus sigma bx square, or sigma xy is equal to, a is a constant, so it will come out of sigma. Again here b is constant, and so so this is the equation 3. We have understood how we have written these two equations. Remember, this is the method of remembering these normal equations. Now we have these normal equations. One is sigma y is equal to an plus b sigma x. Just I am repeating here. And another is sigma xy is equal to a sigma x plus b sigma x square. We have to solve these two equations so as to find the value of constants a and b. A is an intercept and b is slope. From 2, sigma y is equal to an plus b sigma x, or sigma y minus b sigma x is equal to an, or a is equal to sigma y minus b sigma x divided by n. Thus we have found the value of A, and now we will put the value of A in equation 3. Putting value of A in equation 3, we get sigma xy is equal to sigma y minus b sigma x divided by n, and again it multiplied by sigma x plus b sigma x square. We will expand it. N will come this side, and sigma y minus b sigma x multiplied by sigma x plus this term, it will be multiplied by n b sigma x square, or n sigma xy is equal to, this is multiply sigma y sigma x minus b, and we have sigma x 2 times is multiplied by sigma x, so it is sigma x whole square. Mind it, this sigma x whole square is different from sigma x square. Okay, n b sigma x square. Take n sigma xy minus sigma y sigma x is equal to, take b common here, n sigma x square, this term, minus sigma x का whole square, और n sigma xy minus sigma y sigma x divided by this whole term, n sigma x square minus sigma x का whole square, this will be equal to b. This is a very important equation. Thus we have find the values of a and b. B is known as coefficient of regression. Now we have found out coefficient of regression. Then we will know a few things about regression. We will revise the things. We have seen that after observation, we have some data points x1, y1, x2, y2, x3, y3, and so on and so forth. This is x-axis and this is y-axis. Our task is to estimate the value of y, because there is no single line present here where all the observations are lying. So there is a requirement of best fitting line for estimating of, suppose this equation of this best fitting line is y is equal to a plus bx. Then we have to estimate y. Here we saw the error. This is the observed point, and this point is on the best fit line, and this vertical distance is d1. Likewise, this vertical distance is d2, and we have said that this will be a best fit line when d1 square plus d2 square plus dn square, the sum of all these is minimum. Then this will be a best fit line, and we will be able to estimate the value of y. This curve or this line y is equal to a plus bx is called a regression curve of y on x. Why it is called regression curve of y on x or regression line? Why it is called regression line of y on x? Because y is estimated from x. So it is very important to understand it, because your syllabus is heavily dependent on this particular term, that a regression line of, what is regression line of y on x? So using y is equal to a plus bx, we have found out the values of a and b, and the value of b is equal to n sigma xy minus sigma x sigma y divided by n sigma x square minus sigma x whole square. When the regression is done for y is equal to a plus bx, that is regression line of y on x, then we call this b is represented as byx, that is regression coefficient of y on x. It is very important, mind it. And suppose now we want to estimate the value of x from a given value of y, we would use a regression curve of x on y, which amounts to interchanging the variable in the scatter diagram so that x is dependent variable and y is independent variable. We can do the same exercise. Suppose we have another equation. We are interchanging in this equation, x will be dependent variable and y will be independent variable, and we will estimate the value, we will estimate the value of x, and this slope, that is coefficient of regression of x on y, will be bxy. We will discuss this in another video. Before concluding this, it is very important another concept, and that is prove that the least squares line always passes through the point x bar y bar. What is x bar y bar? X bar is average value of all observations of x, and y bar is the average value of all observations in y. We have to prove it. How we will prove it? We are aware that y is equal to a plus bx. This is the best fit line, equation of best fit line. Y is equal to a plus bx. Take sigma on both sides. Sigma y is equal to sigma a plus bx, or sigma y is equal to sigma a plus sigma bx. Further write sigma y is equal to, here a will be written n times a plus a plus a, so it will be na. B is constant, so it will be out from sigma. And another thing, you know, y bar is equal to sigma y by n, average value of y will be sum of all observation of y divided by n. Using it, you can write sigma y to be ny bar is equal to na plus b. Likewise, x bar is equal to sigma x by n. Average value of x will be summation of all values of x divided by n. So we can write x sigma x as nx bar. This comes out to be y bar is equal to a plus bx bar. This is our equation 1, and this is our equation 2. Now use 1 minus 2. Using 1 minus 2, we get y minus y bar is equal to b x minus x bar. What does this show? This shows that the line passes through the point x bar, y bar. You are aware that a straight line, equation of a straight line passing through some point x1, y1 is given by y minus y1 is equal to m x minus x1. Here we have x bar, y bar. So the equation of the straight line will pass through x bar, y bar. So it is a very important result. This shows that the least square lines always passes through the point x bar, y bar. And when we regress y on x, here we have regression on of y on x, so this b will be termed as byx. In the next lecture, we will solve a few problems and then we will see regression properties and we will see other form of value of b that will help us in further solving the problems. Till then,